Okay, class, now we're going to discuss heart sounds. Now, in all the videos that I'm doing and the textbook and everything for the heart, I've added some good movie videos that I'd like for you to look at that can further explain. Mine are more static videos, as you can see. So the movie videos combined with it. So if you put it all together, I think you'll get a very good understanding, even though we're not doing the face-to-face. I think you'll get a fairly good understanding of everything. Okay, so we listen to heart sounds. We take the stethoscope, we put it on your chest. Now, the only thing we have, just to digress a moment, in physical exam are four things: auscultation, percussion, palpation, and visualization. Let's do it again. Auscultation, percussion, visualization, and palpation. So when you come into a doctor's office or nurse practitioner's office, physician assistant, the first thing they need to do is just look at you. That's visualization. Because the minute you start touching, then you can change things. Okay? The next thing they can do is palpation. Okay? Palpation is when you just put your hand on someone. And if you go back in this heart, if I put my hand on your chest, I should be able to feel the heart, and where I should feel it the hardest is the PMI, the point of maximal impulse, which is the tip of the left ventricle generally, which is at the 4th to 5th intercostal space at the mid-clavicular line. Percussion is when we'll thump on your chest, or we'll thump something on you. And that's to try to get the borders. That's to try to get the borders of something. And then we have auscultation, where we put the stethoscope and we listen. Auscultation is where we listen. And that's where we would do the heart sounds. Okay? So those are the things available in a physical exam. All right, the heart sounds, the normal heart sounds are caused by valves closing. The normal heart sounds are caused by valves closing, not opening, but closing. Okay? That's the normal heart sounds. The heart sounds are divided into what we call a sound 1, S1, and an S2. A sound 1 and a sound 2. Now let's think about the cardiac cycle again. Okay. The first time valves should close would be, we'll go over here, when the right ventricle and left ventricle squeeze down, closing on the right side, the tricuspid, and on the left side, the mitral, also called the bicuspid. So the sound 1 is due to AV valves closing. The tricuspid and bicuspid. That's sound 1. Sound 2 is caused when the semilunars close. It's when the semilunars close. That means when the aortic valve closes, when blood falls back on it, and the pulmonic. Aortic, and that comes after, remember, so S1 first, then S2. S1 first, then S2. Now, the first heart sound here, let's go back, the first heart sound, because we're dealing with resolution now, resolution in audiology. That means how close can two sounds be put together and you can still say there are two sounds. So the first heart sound is due to the closure of the tricuspid and the mitral. Now, the left side of the heart does reach pressure faster than the right side. So the left side valve, when it's squeezing down, would close a little bit before the right side valve. So the mitral would close a little bit before the tricuspid. But the millisecond difference between the two is not enough to be heard by the human ear. The millisecond difference between the two is not enough to be heard by the human ear. Okay? Now, on the other hand, the second heart sound, because of the pressure generated in the aorta, the aortic pressure backs up to close the aortic valve, and the pulmonic closes the other. And because of the pressure differentials between the left side of the heart and right side, the aortic pressure and the pulmonic pressure, then those valves do close. So the aortic valve closes quite a bit ahead of the pulmonic, enough to be heard by the human ear. So that's what they call the physiologic splitting of the second heart sound that you may see in the text. The physiologic splitting of the second heart sound, and also maybe in the video. So those are the normal sounds that you have. At S1, closure of the mitral valve, then the closure of the tricuspid, S2. The millisecond difference between A2 and P2 is generally great enough. A2 is the pulmonic. So in other words, S1 is subsumed into an M1 for the mitral and a T1. Because the mitral does close a little bit ahead of the tricuspid, but not enough ahead for you to hear it by the human ear. But S2, the A2 generally will close a lot before. So the time difference between that is generally heard by the human ear. This is called the physiologic splitting of the second heart sound. Now that does change with breathing in and out. We can really hear the separate sounds good if you take a deep breath and hold it. Take a deep breath, because when you blow out and squeeze the chest down, the aortic sound comes closer to the pulmonic. So that's why you'll see us say take a deep breath and hold it, and then we'll move the stethoscope around to listen to the valves. Now you hear my word, move the stethoscope around. These are the spots, and you can glance at it, where we best hear the valves at. Now that's not right over the valve. The reason being, these valves are under the sternum, and the sternum doesn't shake and vibrate. Remember, sound is a vibration. So it depends on where the valves radiate out, and these are the usual spots we want to move the stethoscope around to hear the various good heart sounds. And that's where we look at that. These are abnormal heart sounds. Since we're not in a face-to-face, I'm not going to even get into that. Murmurs are basically due to a turbulent blood flow in pipes. And I'll talk more on turbulent blood flow when we get into the blood vessels. But flow can happen in two ways: a laminar flow and a turbulent flow. Now let me just bring this up real quick. I'll say a little bit. Think about a marching band. A marching band. With everybody marching in line, everything is fine. Nice laminar flow. In a pipe, laminar flow would be a nice flow. The middle goes faster because the flow on the side. So see, everything is flowing in layers. It may seem strange, but in a pipe, fluids flow in layers. Gases do too. However, and laminar flow is quiet. Laminar flow is quiet. But if you have to turbulent, see how this constriction makes things bounce into one another? Then turbulent flow creates a noise. Just like that. And the more turbulent the flow, the louder the noise. So in the heart, when there are abnormal constrictions, we'll say in the valves or so forth like that, that can create murmurs. And the loudness of the murmur in medicine is graded. Is graded. So that's where the murmurs come in. Type of thing there I wanted to bring up. Okay. We go next to what I want to talk on, and I may be able to get it in. We go next to, I'll close this one out here, cardiac output. We go next to cardiac output, and I think I'm going to do a separate video on that. We'll close that here.